Hello, good morning, students. So today we are going to do a new chapter, which is called Integration by Parts, chapter 7.1. So we know that in calculus 1, you know how to take the derivative of a product. So in this chapter, you will learn how to take the integral of a product. So this is very important. Most of the time, you may see a product of two functions, then you can apply this formula or this technique to integrate such product. So I'm going to write the idea behind this. So this is a technique to work with integrals involving the product of a function u of x and the derivative of another function. So we write it as v prime of x. So we are given the product of ux and v prime of x. Then we need to integrate. So that's the idea. So we will consider this integral v u dv, where dv is we write as v prime dx. So we use this notation dv is v prime dx to write down this integral. So the question is, how do we integrate integral x sine x dx? That is a product. Example, how do we integrate integral x sine x dx? So that is the question now we have. So what we are going to do, we will go back to calculus 1 and use the product rule, so that will be helpful. So let's revisit the product rule. From calculus 1. So we are given this product u and v. So we are going to take the derivative with respect to x. That's what this prime represents. So this notation means the derivative. So here we take the derivative with respect to x. So you can apply the product rule. So derivative of first function, which is u prime, times v plus u times derivative of v prime. So that is the product rule. Now what I'm going to do, I will integrate both sides. The next step, integrate both sides. So now I can write this as integral uv prime dx, and the right hand side we have integral u prime v plus uv prime. We integrate with respect to x. So so you know that so this is the derivative with respect to x. So we are going to integrate again with respect to x. So we get answer would be uv. Now we can distribute this integral. So we have u prime v dx plus integral uv prime dx. Now I need to solve this for uv prime dx. So we need to solve this for integral uv prime dx. So what I'm going to do, I will subtract both sides by integral u prime v dx. So then we can get the formula for integral uv prime dx. So we have uv minus integral u prime v dx, that is the integral u v prime dx. Now I'm going to rearrange this. Rearrange this equation. So we can write, so this would be our, so I'm going to write this right hand side into left hand side. So u v prime dx, and this would be u times v minus integral. So I'm going to write v first and then write u prime second dx. So this is what we have now. So we are going to use some notations. So use the notation. So I'm going to use dv, that would be v prime dx, and we use the notation du to represent u prime dx. So with these notations, I can rewrite this equation, the formula. So we have integral u, so I can replace v prime dx by dv, uv minus integral v, so this would be du. So this is the new integral that we have. So this is called the integration by parts formula. The integration by parts formula. So for a given integral, you need to figure out what is u and dv, so then you can apply this formula. So remember, when you choose u and dv, you need to figure out those two such that the integral v du should be very simplest form so that you can integrate it. That's how we will figure out u and dv. So remark, hopefully integral v du is easier than integral u dv. So that's how we need to figure out u and dv. Now I'm going back to our problem. So consider the example. So we had integral x sine x dx. So this is the question we had. So in this case, we need to follow some steps. So I'm going to write in red color. So first step is you need to identify u and dv from the given question. Identify u and dv, and then you need to compute v and du to use this formula. That is the next step. Compute du and v. So once you have those four terms, u, dv, and duv, so you can apply, you can substitute those into the formula. So then apply the formula. So those are the steps that you need to follow to compute the integral using integration by parts. So let's consider again our integral x sine x dx. So in this problem, I'm going to choose u as x and dv as sine x dx. So choose u equals x and dv, which is sine x dx. So in the second step, we need to compute du and v. So since u equals x, we can take the derivative with respect to x. So du over dx is the derivative of x, which is 1. So I can multiply dx to the other side, then we get du equals dx. So that is du. Now we can compute v. So since dv equals sine x dx, so we need to integrate both sides with respect to, so we need to integrate both sides in order to get v. Integrate both sides. So if I integrate, so we have integral dv and we integrate sine x dx. So remember, integral of dv is v and integral of sine x would be negative cosine x. So that is our v. Now we have all required terms u dv and v du. So we can substitute those into the formula. Substitute uv du and dv into the formula. So we can write formula which is u dv equals uv minus integral v du. So I'm going to substitute each term. So we have integral. So in this problem, u is x. So we have x and dv is sine x dx. So this would be sine x dx. And then u is again x. So this would be x. And v is negative cosine x minus integral v, which is negative cosine x, times du. Du is dx in this problem. So this would be dx. So I can write down integral x sine x dx as, so this would be negative x cosine x. So minus minus, that becomes plus integral cosine x dx. Now we need to compute the integral cosine x. So compute integral cosine x dx. So then we can get the answer. So we have integral x sine x dx. That would be negative x cosine x plus, so the integral of cosine is sine. So this would be sine x. So remember, when we integrate, we have to use a constant. So this would be the constant. So that is the answer. So we get negative x sine x plus negative x cosine x plus sine x plus a constant. So where c is a constant. So that's how we will use the integration by parts. So now you got an answer. So let's see how you are going to check whether it is the correct integral or not. So I'm going to do that in red color. So how do we check the answer? So remember, so we did integral. In order to check it, we will take the derivative of the answer. So if we get the derivative as x sine x, so that means we have the correct answer. So we take the derivative with respect to x of negative x cosine x plus sine x plus c. So remember, this is a product. So I will take negative sine x as one term and cosine x as the other term. So then we have to use product rule in order to check this. So we get negative x times derivative of cosine, which is negative sine x, plus cosine x times derivative of negative x, that is negative 1, plus derivative of sine x is cosine x, plus derivative of a constant, which is 0. Now you get x sine x. So this becomes minus cosine x plus cosine x. So these two will cancel out. Then we get x sine x. So that is the answer. So you can see the derivative of this whole thing. We got x sine x, which is in the original problem. That means the answer is correct. Answer is the correct one. Now, so that's how we will check the answer. So remember in our question, so I choose u as x and sine x as dx. So what if I switch these two? So that means I will take dv as x dx and u as sine x. So let's see what we get if we use the other way. So I will do it in green color. So what if we had made the wrong substitution? So what if we had let u equal sine x and dv we will take as x dx. So now again we need to compute du and v in order to use the integration by parts. So we will take du over dx. That would be derivative of sine x. So we get cosine x, that is the derivative. From this we can solve for du, that would be cosine x dx. That is our du. And remember we have dv. So since dv equals x dx, then we get, so v, so integral, so we integrate both sides again, dv, that would be integral x dx. So integral of, So remember, this is 1. Integral of 1 with respect to v, we get v. And integral of x would be, we get x squared over 2. So that is our v. Now again we have u dv and du v. So substitute into the formula. So then we have integral u dv equals uv minus integral v du, gives us, so I'm going to substitute u, which is sine x, and dv, that is x dx, equals u is sine x, times v, that is x squared over 2, minus integral v, which is x squared over 2, times du, that is cosine x dx. So I can bring this x to the front. So we have x sine x dx. So that is the original problem we are given. So we have sine x times x squared over 2 minus integral. So we get x squared 2 cosine x dx. So this is the one we get once we switch. So now we need to compute. So we need to compute this integral. So remember, this is more complicated than the previous one. So this is worse than what we started with. That means, so we are getting more complicated than we are simplifying this integral. That's why, so once you see this, you have to switch the u and dv and then redo that. So then you can get the required answer. So those are the things that you need to consider. So now I'm going to do some remarks and then we will do more examples. So let's write down some remarks. So first remark, you need to think about the choice for u and dv. That is the first thing you need to do. You need to think about the choice for u and dv. The second remark, you need to think or choose dv. So that must be something you can integrate. So if you choose dv as a thing that you cannot integrate, then that will not work in this case. So dv must be something you can integrate. So number 3, you need to do, sometimes you may have to do the integration by parts more than one time. So I will do one example, 1 or 2 examples related to that. So you may need to do parts, integration by parts. More than once. So the last one, so we will consider the definite integral. So we have integral a to b u dv. So we have uv minus integral v du. That is what we had earlier. So in this case, so remember, when you have this, you have to evaluate this uv at x equals a and x equals b, and you have to do this as ab again. So once you have this, you can integrate v du and then evaluate at x equals b and x equals a. That will give you the answer. So those are the 4 remarks that you need to know. Now I'm going to do some examples. So first example, evaluate the integral x e to the power of 5x dx. So in this problem also we have x. So I'm going to choose u as x and dv as e to the power of 5x dx. Choose x, so u equals x and dv, that is e to the power of 5x dx. Now we need to compute du and v, so then we can apply the formula. So since u equals x, we get du over dx. So we take the derivative with respect to x. So right hand side is the derivative of x, which is 1. So if I multiply dx to the other side, I get du, which is dx. So that is du. Now we have dv, since dv, which is e to the power of 5x dx. Then I take the integral both sides. So integrate dv, and we have integral e to the power of 5x dx. So from calculus 1, you have to use the u substitution method. So if you do that, then you get integral of e to the power 5x as e to the power 5x, and then we divide by the derivative of 5x, which is 5. So divide by 5. So left hand side we get v. So that is u, dv, and du and v. Now you can apply the formula. Apply the formula. So we get integral u dv equals uv minus v du. So I'm going to substitute this expression. So u is x. We get x times dv. dv is e to the power 5x dx equals, again, u, which is x, times v, which is e to the power 5x over 5, minus integral. So we have v, which is e to the power 5x over 5, times du. So du is dx in this problem. So we write dx. Now we can simplify. So left hand side we have x e to the power 5x dx equals, so this would be e to the pi 5x over 5 minus, so remember 1 over 5 is a constant, so I can bring it outside, integral e to the power 5x dx. Now we need to compute the integral again. So we have x e to the power 5x over 5 minus 1 over 5 times. So remember, integral e to the power 5x, we have e to the power 5x over 5, and then we have to introduce a constant at the end. So this would be x e to the power 5x dx would be, so where c is a constant. Now we can simplify, so we get integral x e to the power 5x dx is x e to the power 5x over 5 minus, so we get 1 over 25 times e to the power 5x plus constant c. So that is the answer. So that's how we will choose u and dv for the second problem. So now I'm going to do another example. So we will do different questions. Example. So we need to integrate integral ln of x dx. So in this problem look like it is not a product, but we don't know the integral of ln x. So what we are going to do, we apply the integration by parts to get the integral. So solution. Since we don't know the integral of ln x, we will use the integration by parts. So now we have to think about how do we choose u and dv. So we have integral ln of x dx. So in this problem I will go with, because we don't know the integral of ln x, so that means we cannot choose this as dv. We cannot choose ln of x dx as dv. So I will take u equals ln x, and we take dv as dx. So now we can, using these two, we can compute du and v. Since u equals ln x, we will take the derivative both sides with respect to x. So we get du over dx, which is equals to the derivative of ln x, which is 1 over x. Then we get du, that would be 1 over x dx. So now we know du, then we will compute v. So since dv equals dx, then we integrate both sides. So integral of dv would be integral of dx. So integral of 1 with respect to v is, so we can think that way. So this is 1 and this is 1 as well. So integral of 1 is, we get v, and this would be x. So now we have all required terms u dv and du and v. Now I'm going to apply the formula. So we get integral u dv equals uv minus integral v du. So in our problem, u is ln x and dv is dx. So we have u, which is ln x, times v, which is x, minus integral v, which is x, times du. So du is 1 over x dx. Now we can cancel out x. So we get integral ln of x dx equals to, so this becomes x ln x minus, so we have integral, so if we cancel out x, we get 1 dx. Now we know what is the antiderivative of 1, which is x. So we get integral ln of x dx is x ln of x minus, so this becomes x, and we have to introduce a constant where c is a constant. So that would be the answer. So sometimes you can use integration by parts to figure out the antiderivative of a function that you don't know the antiderivative. So next I'm going to do another example. So you will see what is the importance of this when we do this question. So let's write down next example. Evaluate the integral x squared ex dx. So again, we have x squared term. So I will go with, I will choose that as u, and then e to the power x dx is dv, because we know the antiderivative of e to the power x. So solution, let u equals x squared and dv, which is e to the power x dx. Now I can apply the integration by parts formula. So before that, I need to compute du. Since u equals x squared, we get du over dx. That is the derivative of x squared, which is 2x. So from this we get du, that would be 2x dx. So that would be du. And we will use dv, which is e to the power x dx. So if we integrate both sides, integral e to the power x dx, then left hand side we get v, and integral of e to the power x is e to the power x. So that is the v. Now we have all required formula, so we can apply the integration by parts. Apply the integration by parts. So you get u dv equals uv minus integral v du. So in this problem, we choose u equals x squared. So we have integral x squared, and dv is e to the power x dx. e to the power x dx equals u, which is x squared again, u equals x squared, and v is e to the power x minus integral v is e to the power x times du. Du is 2x dx. Now we can simplify. So left hand side we have integral x squared ex dx equals, so we have x squared e to the power x minus, I can bring this 2 outside, so we have integral x e to the power x dx. So I will take this as equation 1. So remember, so we have to compute the integral of x e to the power x. So we don't know the antiderivative of x e to the power x. So what we need to do, apply the integration by parts again. So then we can get the answer. So what I'm going to do, I will choose u and dv. Now we need to apply integration by parts to the integral x e to the power x dx. So in this problem, again we will go u as x and dv, that would be e to the power x dx. So then we will compute again du and v. Since u equals x, we get du over dx. That would be derivative of x. So in this case, it is 1. So du is 1 dx, which is dx. That would be du. And then we will compute v. Since dv equals e to the power x dx, we will integrate both sides to get the answer. So integral of dv, that would be integral of e to the power x dx. So integral of 1 with respect to v, we get v, and integral of e to the power x is e to the power x. Then we can apply the integration by parts. So we have integral u dv equals uv minus integral v du. So in this problem, u is x and dv is e to the power x dx equals, so u, which is x, times v, we get e to the power x, minus integral v is e to the power x times du, that is dx. Now we can substitute this. So I will take this as 2. So substitute 2 into equation 1. Substitute 2 into 1. Then I get, so we have integral x squared e to the power x dx. So we can write this as x squared ex, x squared ex minus 2 times. So we have this expression for integral x ex. So we have x e to the power x minus integral e to the power x dx. Now we can multiply these two terms by negative 2. So we get x squared e to the power x minus 2x e to the power x. So if we multiply these two, we get plus 2 times integral e to the power x dx. So that is x squared e to the power x dx. Now we need to compute the antiderivative of e to the power x. Compute this integral. So we can write down the answer. So integral x squared e to the power x dx, that would be x squared ex minus 2x e to the power x plus 2 times. So antiderivative of e to the power x, we get e to the power x plus, then we have to use a constant where c is a constant. So that is the answer. So we have, so remember in this problem we had to apply 2 times the integration by parts. So sometimes you may have to use more than 2 or more than 1, doesn't matter. So you have to compute the integration by parts separately and substitute back to the original problem. So that's how we will do this. So I will stop here. So redo these problems. So in next video you will learn so important problems. So sometimes we will use the integration by parts, maybe more than one time. Then we get back to our original problem. So how do we handle those kind of problems? So I will discuss those in the next example, next video. So I will stop from here. Have a good day. If you have any questions, feel free to contact me.